Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I will present my bachelor degree final year project 1. So the title of my final year project is Biosorption of Heavy Metal Removal in Groundwater using Immobilized Microalgae Alginate Bead Botryococcus. Let me introduce myself first. My name is Siti Shazwani binti Muhammad Ahya, metric number AN180031. So in this final year project, my supervisor, Associate Professor T.S. Dr. Nur Shuhaila binti Muhammad Sinar, and my co-supervisor, Dr. Najiha binti Muhammad Apandi. So, the project outline: first, background of study; second, problem statement; third, objective; scope of study; significance of study; literature review; methodology; expected result; and Gantt chart. The increasing of population and industry contribute to environmental pollution, which can threaten to the human life. So the main issue for this study is heavy metal contaminant in groundwater. Groundwater is the under domestic wastewater that's generated from the house, office building, and institutions. Many contaminants in the groundwater, such as greywater and pathogens. So the solution to remove heavy metal in the groundwater is phycoremediation process. Phycoremediation is a process to remove contaminant in the wastewater, such as heavy metal, pathogens, and nutrients by using the microalgae. So in this study, the immobilized microalgae beads are used to remove the heavy metal in the groundwater. So the atomic absorption spectrometer AAS and inductively coupled plasma mass spectrometry ICP-MS are used to measure the concentration of heavy metal in the groundwater. So the expected outcome from this study, the immobilized microalgae beads can reduce the concentration of heavy metal in the groundwater. Issue of groundwater. Heavy metal ions such as cadmium, zinc, plumbum, copper, ferrum, and manganese are produced from the detergent, soap, and body care products. So the bathroom and laundry activity release the light groundwater that contain the concentration heavy metal from the detergent and the soap. So the groundwater will discharge to the river without any wastewater treatment. So from this situation, it will give the negative impact to the human health and environment. Problem statement: groundwater in the wastewater also can be classified into domestic, industrial, and agricultural wastewater, and most wastewater is dangerous to human health and environment. From the total domestic wastewater, the groundwater production are the highest ones, which in range 50% to 70%. The untreated groundwater discharge without control can cause negative impact to environment, human and aquatic life. So effect heavy metal in the groundwater. Heavy metal is difficult to biodegrade in the environment. The toxicity of heavy metal can cause infection to the lungs and liver, also can cause the cancer. And the copper in the heavy metal, which from the water pipe, copper water heater, and cooking pots, can cause the anemia and insomnia. And followed by the lead, can cause the livers, kidney damage, and the birth defects. Microalgae is the best solution to treat the wastewater treatment since it is environmental and friendly, cost-effective, and low maintenance. So many technologies and scientists are prefer using the microalgae as the first choice in any treatments more than using chemical substance which can give a side effect from the wastewater treatment. The objective in this study: first, to measure the formation of microalgae beads loading capacity for heavy metals absorbing in groundwater. Second, characterize the immobilized Botryococcus by using FTIR and SEM-EDX before and after absorption. So the scope of study: first, the microalgae beads will be optimized for the purpose of heavy metal removal in groundwater. Second, physical characterization, scanning electron microscopy and Fourier transform infrared spectroscopy and chemical characterization methods will be employed. Significance of study: it is potential to remove heavy metal from greywater using phycoremediation process by alginate beads of microalgae Botryococcus. By using microalgae Botryococcus, it keeps environmental friendly and reduce the chemical use in wastewater or greywater treatment. The microalgae beads are effective technique to remove heavy metal contaminants in the greywater such as ferrum, cadmium, cuprum, and zinc. It is important of biological treatment compared to the chemical treatment. From this treatment also, the economy can control without spend a lot of money to control the pollution in the greywater. Literature review. Greywater. Greywater production in a range 50% to 70% from domestic waste, and greywater can be reused and treated within 24 hours. And the suitable condition to reuse the greywater is during climate change, lack of water resource, and prolonged dry seasons. So the greywater can be used for irrigation, toilet flushing, first rinse of dishwashers, and washing machine. So from the chart, the domestics have two types, which is greywater and blackwater. Greywater are from the bathroom, laundry, and kitchen, and blackwater are produced from the urine and feces. Sources of greywater. Greywater from bathroom that derive from shower, bath, laundry, and hand basin consists of 30% of household greywater flow. Greywater from kitchen and laundry contains more organics and physical contaminants, and the soap and detergent are alkaline, which the greywater pH shows in range 7 to 8. Amount of greywater is depending on the household and humans' activities in daily life. Light greywater are wastewater from bath, shower, bathtub, hand basin, and bathroom sinks, while dark greywater from laundry machine, washing machines, and rinsing. Effect of greywater. The common elements in greywater are heavy metals in the detergent products with different concentration which can harmful to humans, plants, and aquatic life. Effect of greywater to humans. Cadmium and zinc ion can cause the gastrointestinal and respiratory damage, including damage of brains, heart, and kidney. The contaminant of pathogens can cause the foodborne illness and decrease adult reproductive potential. The effect of greywater in aquatic that absorbs into the fish body tissue causes high mortality of aquatic life. And the effect of greywater to soil, the sodium contaminants can decreasing composition and permeability of soil, and the alkaline detergent will supply in soil particles and leading to an increasing in soil cation exchange capacity. Microalgae Botryococcus. Microalgae are photosynthetic microorganisms that can be found in both marine and freshwater, and they included bacteria, cyanobacteria, diatom, and unicellular plants, chlorophyta. Botryococcus and the Scanodermus are suitable material for wastewater treatment and biomass production. Botryococcus is a green colonial microalgae chlorophyta with extremely high renewable hydrocarbon and chemical content, and it can be found in the fresh and brackish water or universe. In the lipid content, Botryococcus can generate up to 80% compared to other species such as Sclerodermus obliquus 30%, Spirulina platensis 9%, and Neochloris vegansis 19.29%. They are the example for the Botryococcus. Phycoremediation process. Phycoremediation is the process of using algae to absorb nutrients, collect heavy metal, and reduce organic contaminants via interaction of aerobic bacteria. They use treatment of high organic content wastewater and industrial effluents, nutrient removal from wastewater, and pathogens eliminations. Example of application phycoremediation: organic removal from organic metal-rich wastewater, heavy metal-rich wastewater treatment, and toxic compound detection using algae-based biosensor. The advantage of the process: cost-effective, environmental friendly, and secure, lower nutrient load and total dissolved oxygen, easy operation and maintenance, and long-term treatment solution with substantial energy and nutrition recovery capabilities. Heavy metal in groundwater. Surface water harms when heavy metal bearing influence released to the environment. The toxic heavy metal ion in wastewater must be eliminated before discharge into the environment. Heavy metal are harmful to human health by reduce the growth as well as illness, including cancer, organ and nervous system damage, and ecological destruction. Concentration of heavy metals such as zinc, cadmium are effect to the soil, crop production, and public health such as human degenerative illness such as Alzheimer's disease, Parkinson, and other if the concentration exceeds the maximum permissible in water. Methodology. From the chart, first, greywater sampling. Greywater sampling got from the bathroom greywater from one's residence at Kampung Melayu Raya Sagil. And second, immobilized microalgae alginate beads we provided at Environmental Laboratory, Faculty of Engineering Technology. Next, microremediation process. In this process, have 5 sample greywater in the 700 ml. And every sample have different capacity of alginate bead, which is 200 gram, 400 gram, 600 gram, 800 gram, and 1000 gram. So every day, the sample will still 2 times, and the total days for this process is 18 days, and every 3 days, we will check the concentration of heavy metal in the sample. So next is heavy metal analysis. Two equipment, atomic absorption spectrometer and inductively coupled plasma mass spectrometry. So next is characterization of microalgae beads before and after adsorption. Use two equipment, Fourier transform infrared FTIR spectrometer and scanning electron microscopy SEM. So the last is result analysis for the both parts, which is concentration of heavy metal and characterization of the microalgae beads before and after adsorption. The location for the greywater sample at Kampung Melayu Raya Sagil, Ledang, Johor with coordinates given. And there are the example for the immobilized microalgae alginate beads of Botryococcus. The equipment used for measure the concentration of heavy metal and the characterize of microalgae beads. First, inductively coupled plasma mass spectrometry, ICP-MS. Second, Perkin-Elmer spectrum 100, FTIR spectrometer. Atomic absorption spectrometer, A analysis, 800 Perkin-Elmer. And last is scanning electron microscopy, SEM-EDX. Expected result, the increasing of immobilized microalgae beads loading capacity used in the samples is expected will reduce the concentration of heavy metal effectively. When the loading capacity of microalgae beads used are decreased, the concentration of heavy metals in greywater sample will be increased. And the physical characterization of microalgae beads before and after absorption using FTIR spectrometer and SEM-EDX spectroscopy. This is my Gantt chart. The total week is 15. The activities start from determine title, discuss the title, write the report for chapter 1, chapter 2, chapter 3, and chapter 4. Do correction and submit the final draft. Make slide and video presentation. Submit of approved FYP proposal and presentation to the panel. And last is question and answer season with panel. So write report for the chapter 1 in 3 weeks, and write report for chapter 2 in 4 weeks, include the mid-sem break. And in the week 14, do correction and submit final draft report to supervisor. Make slides and video presentation and submit of approved FYP proposal and presentation video to the panel. And the last, question and answer season with panel at the week 15, 30 June 2021. There are several references from my studies, which is about the microremediation of heavy metal, Potential of biodiesel production of Botryococcus, microbial and plant assisted bioremediation of heavy metal, and bioenergy production of metallic ion conversion from Botryococcus. So that's all from me. Thank you.